Thank you so much, Alex, for this nice introduction. You stole the content of my first few slides, but hello, NODES2022. I'm so happy to be here today. Great to see all those people interested in graphs as always. And in my session, as Alex said, I would like to show you some cool graph visualization tools. For many of the great use cases for a graph database, visualization is a super valuable tool that you should be aware of, and it doesn't have to be complicated, as you will see. Specifically, I'll talk about visually exploring your Neo4j graphs with Jupyter notebooks and simple literate programming. Whether you're a software developer or a data scientist or a database administrator or a project manager, my talk should give you some ideas on when you would want to be using graph visualization to better understand the data in your Neo4j databases. After my talk, I bet some of you go and try this on their own data. It's safe and it's easy and it's free, and it's always exciting to get to actually see your graph data in a meaningful way for the first time. So some more details about myself. So together with my team at yWorks, I've been working in the field of graph and diagram visualization for more than what's soon going to be 25 years. And our tagline is the diagramming experts, and we help teams and enterprises worldwide with their graph visualization tasks. As graph drawing specialists, we have seen a huge number of use cases and data sets over the years. We've been working on and providing high quality tools and support to our customers and the community around that topic. And the tool we'll be looking at today is just one of these tools. So here's the agenda. What will you learn today and what are we going to see in the session? We'll be looking at easy ways to work with Neo4j databases plus the Neo4j Graph Data Science Library in the context of Jupyter notebooks. But don't worry, although this will also mean we'll be looking at some lines of code, this is not going to be really difficult. We'll look at automating visualization tasks with the help of literate programming in notebooks. I'm going to show you how to create custom visualizations that will help us and our users better understand the data hidden in our graph databases. So for this, I'll show you how to set up Jupyter notebooks to connect to Neo4j, use Cypher to query the database contents, and the Graph Data Science Library to optionally perform some analysis tasks. And we'll see how to create graph visualizations in Jupyter notebooks and labs. They won't just look beautiful, but we will also make sure to include the information in the visualization that we want to provide our users with. So here's a quick overview of how all the things are connected that I'll be using today, pun intended. The focus is on yFiles graphs for Jupyter, which is at the top, and the left half basically explains how all this works and adds some context. So yWorks, the company I work at, creates a software development kit called yFiles. It allows software developers to build sophisticated graph visualization applications with great automatic layouts and rich custom interactions. And the Jupyter widget we'll be looking at today is also built on top of that library. And by the way, those tools at the center, they are all free to use, so they don't require registration, and the lower two don't even require installation or download. You can just use them for free on our website. I will only briefly speak about the Data Explorer apps in this session. These belong to another set of tools to interactively explore connected data. And one of them can be launched directly from within the Jupyter widget, as we'll see, but they can also be used standalone without the Jupyter context. Actually, at last year's Nodes conference, I dedicated a whole session to the Data Explorer for Neo4j, and even more so the app generator, so I won't be covering it this time. But feel free to browse the archives and watch the recording after the conference. All of these tools have built-in support for Neo4j databases, so all you need to get started is a set of credentials to access your database. Read-only access is enough for many use cases, and the data never leaves your systems or touches our servers. So there's a direct connection between your machine and your database, and you can run the tools offline behind a firewall if you wish to. So don't be afraid and just try it. Okay, so let's take a look at the Jupyter Notebook plugin. And by the way, the plugin's issue tracker is on GitHub, so when you use it and feel like it's missing a feature, please do file an issue on GitHub. And the plugin is under active development, and the more people find it useful, the more time we can actually invest into the tool. So this is what the plugin does. It provides interactive graph visualization and exploration capabilities in the form of a widget that can be embedded in Jupyter Notebook and Jupyter Lab notebook cells. So you can use it to visualize connected graph data, well, from many different kinds of different data sources that you have access to from your notebooks. And of course, this includes Neo4j graphs, which are supported right out of the box. This enables you to visualize the graph results of Cypher queries. So the main difference to the Neo4j browser, where you can do similar things, is the target audience and thus also the support for more sophisticated use cases. While the Neo4j browser is essential for database administrator tasks, it's not so much a great scripting environment. For one, it's basically limited to running Cypher queries. But in a Jupyter notebook, you can do that, but you can do so much more. As a data scientist, you can write complex interactive notebooks that dynamically query data from various sources, do sophisticated pre-processing, and then combine this with any number of Cypher queries to create a far more complex and hopefully helpful visualization. Also, with the widget, you can apply various automatic graph layouts to the graphs in order to highlight the different aspects of the structure and the connectivity in your data. And with advanced custom rules for the visualization, you can add style to your nodes and relationships in the diagram and make it easier for the user to quickly see the important data. So we'll get to this in a minute. Installing the widget is easy. For example, you can just use pip install. So if you have used Jupyter Notebooks before, that should be all familiar to you. Here in this example, I'm also installing the Neo4j and Graph Data Science packages for later use too. Note that you might need to restart the Jupyter server after this, and please be aware that the functionality at this time, unfortunately, for compatibility reasons, you should please open them using a regular Jupyter Notebook or Jupyter Labs server. It doesn't work in all third-party viewers like Visual Studio Code yet. So now let's take a look at the working widget. This over to the live demo. So I have a plain Jupyter Labs installation plus only the packages from that last slide. So the Graph Data Science one isn't actually required to connect to Neo4j, but of course having the Graph Data Science library available in a Jupyter Notebook really allows for some very cool use cases. For the upcoming examples, I'm using the airports example database that comes with one of the Graph Data Science tutorials. So I have set up a Neo4j ORDB instance with Graph Data Science library enabled, and I uploaded the sample database data before. So this means I can now run Cypher queries right in my Jupyter Notebook using the Python API. So here I'm importing the graph database object from the Neo4j package in my Jupyter Notebook cell, instantiating a driver and the session with a certain database, and then I run the Cypher query over here. So far, nothing special. And this is all just the regular Neo4j API available in the Python Jupyter Notebook version. What I'm doing here is the result of the Cypher query, I'm calling the .graph function to get the graph as an in-memory data structure. If I execute the cell, I get to see this as the graph, which is, well, not really helpful because there is no built-in support for visualizing graphs at the Neo4j level inside Jupyter Notebooks. So this is where our plugin comes in handy. So what I'm doing is I'm just importing this graph widget object from the yFiles Jupyter Graphs package and calling the constructor to create a widget. And I'm passing in the graph instance from the cell here above. So this is a Neo4j graph, and Neo4j graphs, just along with some other graph formats, are supported out of the box. So I don't need to do anything special to visualize my Neo4j graph. All I do is execute this cell, and this actually launches the widget. So this is the widget, and it consists of two panes where there's the central graph visualization, and if the graph is larger, I can actually use this overview here over here to navigate my larger graph, but in this case it's small enough so I can just like collapse it. And then there's this sidebar with additional information. I can also expand my screen, so in case my visualization is really large, so to see more. And then I can navigate the graph by dragging it around or using the mouse or the buttons to zoom in and zoom out. Hovering over the items shows me the properties that are attached to the in-memory graph. And these are the properties that are actually from the Neo4j database. So if you look at these these are exactly the ones that you get from the database, and the label is the Neo4j. The item named label here is the Neo4j label. So this is a city, an airport, countries, and so on. The same goes for the relationships, and clicking on them, I can use the side panel to take a look at the data in a more static way, and for example to compare items. I can with control click, and I can select multiple elements and see there and compare their values right inside this panel over here. But it may be difficult to identify a certain item, and that's what the search panel is for. So I know that there should be Atlanta somewhere in here. So I just look at this, and this lets me focus the node inside the graph, because right now all I see is that this is an airport. So I would have to like hover over all these elements or click them to see which one is the Atlanta port. So we're going to improve the situation in a minute, because by default, if you show the widget, you will only get to see the node labels and the relationship types right in the visualization, and you have to look at the data panel to see more of the properties. So that's not yet a great visualization, and we'll change that in a minute. But before I do that, I'll show you the last tab we have over here, which is a neighborhood view. And this is a contextual view, meaning that whenever I change the context by selecting an element over here, I get to see the immediate neighbors of that selected nodes as a small utility graph. And in this case, all neighbors one hop away. So I can change the number of the depth over here interactively to get to see the neighbors of the neighbors and the neighbors of the neighbors and the neighbors and so on. And I can use this to actually navigate my graph. So rather than having to work on this view, I can click on these items and they will both synchronize. So whether I'm clicking over here or there, this lets me navigate my graph. And of course, there's also the properties view in here. So that's the basic setup that we have for the widget and what it does. And it's just one line of code away. But as I said, to make this more useful, we have an API provided, because this is actually a powerful API that provides you with methods and functions and properties to customize the visualization to match your requirements. So let's take a look at how that would work. So again, I'm running a Cypher query here in this example, which just queries a number of airports and their cities, how they are related. And later on, I will be passing the graph here to the widget again, but rather than directly showing the widget, which happens when I just write this one, I'm first configuring some of the properties. There's properties that have an influence on the general visualization, so like overall properties that affect all the items, like directed, which tells which is whether my graph that I'm displaying should by default contain arrowheads at the end of the edges. So for example, in the social networks where all my relationships are like knows, and they are person 1 knows person 2, then it's probably a symmetric relationship, and I don't want to show them as a directed relationship. And I can also switch the graph layout, because this is something I forgot you to tell about here, is that apart from the default organic layout that we see here, which is a force-directed layout, there's this menu item here, which lets me choose different automatic layouts. And different layouts allow you to highlight different aspects of the graph. For example, the hierarchic layout shows me that this is actually a bipartite graph that I got from the query, which is pretty obvious, because the query basically was to match airports and their first-degree neighbors. And since those are all directed edges, we see that there's airports all on the one-hand side of the graph, and the continents, cities, and regions on the second partition. So choosing an automatic layout may help your users better understand the data. And to help them choose the right layout, you can do this programmatically too. So here in this example, I'm choosing the orthogonal layout to be used initially. I am also configuring the neighborhood view that I just showed you so that it will be using 3 levels, and initially we'll be using in this case, the first node from my graph. And of course I could be using more complex logic in here, like finding a certain node and showing that node in the neighborhood. I also configure the visualization to not show the sidebar initially, and once the user opens the sidebar, we want to see the neighborhood immediately. And also, just for the sake of showing more features, I'm disabling the overview graph visualization in the top left corner here initially. But now for the good parts, the cool parts, the really useful parts, is for changing the visual appearance of the various nodes in here. So as I said before, then by default all of the nodes look the same, and they have the same, they only have the static label in there, and we would like to change that. And they also have the same shape, color, and the edges have the same thickness, and you can change all of this dynamically and data bound. So the most simple form is to, well, just change like the color of all the nodes. And this works by using a custom mapping. So this is a mapping function. For each node, it will return blue. Well, that's a pretty similar and actually not quite useful mapping because, but this will change the color of all the nodes. But we can get more sophisticated and use the data that is bound and available at the various items to drive the visualization. So in the second line, I'm determining what color to use for the edges in my graph. And we'll be using orange if it's actually a in-city relationship, and all other edges will be black. So this is using the properties that are available in memory, and there's this extra label property which is mapped to the Neo4j relationship type. Just for convenience, they have both been called label here in this case. So we're checking the relationship type, whether it's the city, and then we'll be using orange lines and all black for the other ones. So, but apart from only specifying constant values, you can also make really dynamic values, and specifically for the label mapping, if we look at the airport, there is other information that we would rather like to see directly in the visualization. For example, I would prefer seeing the IATA code and the city name for each of the airports directly in the visualization. So what I'm doing here is I'm declaring a mapping function for each node from the node properties to a label. And what I'm doing is here I'm querying the IATA code and the city property of the node, combining this with a new line character, and I'm only applying this to the airport nodes because the other nodes don't have these properties. And for all other nodes, I'm just using their name property, which in this case is the city, and city actually has a name property. So this should result in a nicer label and a much more usable graph. Last but not least, there's also the option to change the geometry of the elements. For example, if I want to change their size to like indicate the importance of those items in my visualization, I can specify a scale factor on a per item basis. So in this case, for example, if we would be looking at the airport nodes, we see that these airports actually have information about the number of runways each airport has in this data set. So one could argue that a larger airport has many runways, and I would like to highlight these larger airports by increasing the size of these nodes. So this is what I'm doing here. I'm accessing the runways property of the nodes. I'm dividing it by 4 and adding 1 to get values like 1, 1.25, 1.5, 1.75, and so on. This is just an arbitrary function that I came up with, which worked nice for my example. And all other nodes won't be scaled, so they will stay at their original size. So let's see how that works out. So this is the new graph, and as you can see, it has a different layout. It uses the orthogonal layout. The nodes are blue, and the in-city edges are actually orange. And for the various nodes, you can see that the code and the city name is actually rendered right on top of the nodes. And if I open the sidebar, it directly starts with a neighborhood, and I just accidentally clicked the element. But once I reload this, you would see the one that I specified in code to be highlighted and shown immediately in the neighborhood view. Okay, so this is just a little bit of coding, and you don't want to like repeat this for all of your experiments. So what you can do, of course, is with just a little helper function that I created here, and I called it create airport graph, and it does all of the stuff that I just showed you in encapsulated away in a simple function with some simple configuration. So that's just very simple Python, and I won't go into the details, but it basically does the same that I just showed you with a few more convenience things. So this means that once I execute this cell, I have this function available in my Jupyter notebooks, and now displaying a graph from my database is really easy. I just need to call one function and pass in the graph. So again, I'm running a Cypher query. This time there's airports, cities, regions, countries, and continents in there. And when I run this function, I get this result. And now you can see that it's looking much nicer than before, because the nodes have different shapes depending on their type. We see the right labels. We see different colors and so on. So, okay, nice, but still not super useful, you might think. However, you can start to see that with the hierarchical layout, for example, with the right layout, it's getting much easier to understand the structure of your data. Now you see that in your database, there's always these, or at least in the query, there's always these airport nodes connecting to cities, connecting to countries, and to continents. So that's a nice representation of our data that we got here. But now let's add graph data science to this and make this really powerful. So because since this is in a notebook, I can actually use third-party packages and APIs like matplotlib or pandas to add more features to this. So this is a little bit of programming. So what I'm doing here is, it's not that much code, and what I'm doing here is using the graph data science module to actually first calculate some graph data science, in this case, the PageRank algorithm to calculate some scores for all the airports, because suppose I want to compare the various airports in my database and see how they compare with regards to the PageRank algorithm. So what I do here is, and I won't go too much into details, I'm using the graph data science module to project a subgraph which only consists of the airport nodes and the has-route relationships, because that's the network of how the different pairs of airports are connected, whether there's a flight available between them. And the has-route relationships in our database connects all the database, all the airports, and with the PageRank, I can get a measure of how important or how central a certain airport will be. So calling the GDS library, I get an in-memory result that I can work with in my Jupyter Notebook cell. And since this is actually a pandas table, I can use the pandas API to, for example, filter the table and only include those nodes that are above a certain score. So I don't get to see the super unimportant airports according to my measurement, for example. So what I'm doing is I'm filtering the table, and then for display, I'm again executing a very simple Cypher query. So I'm just loading the nodes that I got from the results from the graph data science algorithm. So this will just load the nodes with a score larger than greater than 1.5. So we're loading this and displaying this graph. Then I'm again setting the labels over here, but also I'm setting a custom scaling, which actually uses the ranks that we just calculated to scale the nodes according to their ranks. So, and I can use a custom function here. So any function that suits my use case, I can just code here, because this is all just Python code, simple Python code. So I'm using a square root function, so not to scale the nodes linearly with respect to their scores, because that would lead to super huge nodes in the visualization. So I thought that using square root works well. And what I'm also doing is I'm using the rank information to color map the nodes. So I'm using a third-party library. This is from matplotlib to get a color map, which basically gives me a nice gradient of different colors. And I'm using, I'm mapping the range of the values that I have in my data set, in my result set, to map them to these colors. Last but not least, you may have seen that in the data set, the airports actually have some interesting properties called lon and lat, which is actually longitude and latitude. So these are geo-coordinates. So I am using another mapping that I can specify here, which is the node position mapping, which allows me for each node to specify where on the screen I want it to be placed. So why not use the geo-coordinates for that? So I'm just using this super scientific formula over here that I came up with, multiplying the longitude value by 150 and the latitude by minus 200. And if I run this, we get to see this. A DNS hiccup, but there's the results. So, and if you look at this, you will probably recognize that over here, there's actually Europe. This is the world map. There's Asia over here. Somewhere here should be Australia, South America, and the US. And if we zoom in, we see that there's these airports over here. For example, this is Paris-Charles de Gaulle, an important airport, which we see because it has this light green and the larger size, according to our measurements. So that's some nice combination of graph data science, visualization, and geocoding. But it's not really a graphy example. So as a last example, we're going to use graph data science to do a really graphy task, and that is calculating a shortest path. So we'll be using the shortest path algorithm from the graph data science library to calculate a shortest path between a set of airports. And for this, again, I'm creating a projection for the graph data science library, which contains the airports and has route relationships only. And we're including the distance property, which is available in our data set. So there's someone calculated the distances between all those airports, the flight distances. And we use these distances to calculate the shortest path between one pair of airports. And I'm using this utility function from the GDS library to load these airports. In this case, it's Stuttgart and ART, calling the shortest path method. And what this results in is just a set of nodes, just a set of airport nodes. So because the graph data science library only ran the query, the algorithm on the airport nodes, and it doesn't have the information about the other nodes that we have in there, like country, location, city, country, continent, and so on. So what I'm doing next is, with those results, again, I'm doing another query to actually load a subgraph from the full database. And this contains both the airports that we've got from our result nodes, as well as the connecting route between them. But for each of the airports, we also include the chain of the city, the region, the country, and the continent for both the source and the target nodes. So this will result in a visualization that contains the shortest path between str and art, and all the intermediate path elements, if there are any. And for each of the intermediate path elements, there's also information about well, the location of these. Then I'm using the function that I used before, and that's the only part where actually our widget comes into play. So this is all unrelated to the widget. And if I execute this, I get to see this result. Let's take a look at this. The hierarchical layout is probably best, because what we see here is this is our shortest path. That's from Stuttgart Airport going to London Heathrow, Philadelphia, and ART, that's Watertown International Airport. And we also see the distances between those elements. And for each of those elements, we see what city, region, and country they are in. So we see that Stuttgart and London is both on the continent Europe, and the other two airports are in the US, and the US is, according to this data, is actually North America, and I believe it says it's also in Africa, which is probably not correct, but that's a problem in the data and not something that we will have to work with today. It also says that London is both in England and Canada, so that's likely an issue that we have in our data. But yeah, this is nice. So this makes for a nice visualization of our results. But we can do more. And as a last step, I'm going to show you an integration that we just added to this plugin, and that is an integration with our suite of Data Explorer applications. So with all of these results, I can just open them in an external application that we have hosted on our website, which lets me visualize and explore the graph in a different way. And this is actually outside the scope of the Jupyter lab extension. So this could also be used with different data sources. And we have the same one for Neo4j. So, but this is different. So it's not going to the database. It's just allowing you to explore the schema and the data from the query that you had in your Neo4j notebook. So I can just like iteratively load the other elements in here and explore them, just as you might know it from the Neo4j browser. And I can also, in this case, just reveal the entire graph. And now what's the difference here? I can get much more sophisticated with regards to visualization. So there's options to style those elements, and it took me some time to come up with a nicer styling. So I prepared this one. So let me just load them in. And now we have like super cool visualization that's only possible within the Data Explorer here, where you have like, there's icons in there and there's additional code in there. So that's much more sophisticated than what we've seen before, but it's also more helpful and more end user friendly, so to say. And what's also unique to this application is the last thing, and that is that if we look at the schema, we actually have the geo-coordinates in here. So wouldn't it be cool to see those nodes actually on a map view? And this is what we can do in here. I mark this property to be used as map coordinates. And now if I go back to the Explorer and hit the map layout, I finally get to see my route, which goes from Stuttgart via London Heathrow over to Philadelphia and Watertown. Okay, so much for this application. Let's see the summary. We arrived at the summary slide, hopefully in time. I hope I was able to show you that creating visualizations from your Neo4j data with the help of Jupyter Notebooks is easy and powerful. If you're a data scientist working with Jupyter Notebooks, you can use the yFiles Graphs for Jupyter plugin as an entry point to render your Neo4j Cypher query results. And you can combine the powerful tools and scripting capabilities that you get from Jupyter Notebooks to create bespoke, helpful visualizations, run graph data science algorithms, and interactively explore your graphs, both directly in the notebook as well as conveniently in the generic Data Explorer app. That's it for now. We would love to hear your feedback about our tools. It's your input that helps us continuously improve them. So try the tools, share them with the community, leave us a star or a like in the social media, or of course, contact us directly. I'll also hang around in the chat and I'm happy to answer your questions there. As always, happy diagram with your Neo4j databases and the visualization tools by Wireworks. Thanks, and everyone enjoy the conference. Back to you, Alex.
It was great. People seem to like it as well. I see lots of clapping, so that's always good or encouraging, because virtual conference, so we don't hear your clapping. You need to emoji the claps.
Thank you so much.
We are a little bit over time, so we don't have much time for questions, but I think we can squeeze in one. Comes from Michael. Does it work in Google Colab? Because you said there's some restrictions on the usage. In the beginning.
At this very moment it doesn't, but this should be actually doable, and this is actually very high up in our roadmap, so I hope we're going to see Google Colab support in one of the next versions, probably, if all goes well, in Q1, meaning early in 2023. So yeah, it's up on our roadmap, but at the moment it doesn't, so really Jupyter Lab or Jupyter Notebooks. Sorry for that.
No problem. And then from Jason, maybe we squeeze this in as well. Will you share your notebook file with your presentation, or make it public somewhere so people can?
Yeah, I can do that. There's already a simple example which I actually based my slides upon, is already on the GitHub repository of the plugin. So there's a generic Neo4j example and the GDS example. So, but I'm going to share this specific one too soon.
Okay, perfect. Well then, thank you very much, Sebastian. Thank you for the great presentation, and yeah, see you soon on another Nodes conference or Neo4j event.
Thank you. Have a great day.
Thank you.